Okay, now, if we've got the LU decomposition of A, we can write the matrix equation AX equals B as LU times X equals B. Okay? Now, to solve that equation, we could start by multiplying by L inverse. L inverse times L would give us the identity, and the identity times U is just U. So we'd have UX equals L inverse times B, wouldn't we? So we'd have our L inverse times B that I've written down here. Then if we multiply by U inverse, remember U is out there unprotected now, we just get X equals U inverse times L inverse times B. So, writing it out formally, we've got U inverse L inverse multiplied by LU times X equals U inverse L inverse multiplied by the B matrix. Just multiplying both sides of this by U inverse L inverse. And as we've seen, this kind of product is going to just reduce down to the identity, so we just have X. And X is going to be U inverse times L inverse times B. Okay? Now what good is that? Well, let's observe that if Y equals L inverse B, then Y is a solution to the equation Ly equals B. Now we haven't established it, and I'm probably going to go back and insert a video before this one to establish that it's really easy to solve the system by back substitution, actually forward substitution if it's a lower triangular matrix. Ly equals B can be solved just by substitution, because what does Y equals B tell us? It tells us that the coefficient of the first variable in our Y column multiplied by whatever number we get here from our lower triangular matrix has to equal the first element of our B. Now you may be a little lost what that means, and as I say, I will have inserted a video to show what that means, and to solve this thing by forward substitution, which is, you know, an assigned problem that you should already have done. Regardless, we'll demonstrate that. So Ly equals B is really easy to solve. Okay? So it's going to be easy to get Y by, and I wrote back substitution, it's forward substitution. So and back substitution and forward substitution feel exactly the same. They look just slightly different, but the process is pretty much conceptually identical. Okay, well anyhow, so it's easy to get Y. Take my word for it. If you got Ly equals B, you can easily get Y. So, and that would be, that Y would be L inverse B. So it's easy to get L inverse B, and we call that Y. Okay, so now you got X equals U inverse Y, don't you? So it's like you have X equals U inverse L inverse B. Well, that equals U inverse Y, where Y is what you get when you solve this. And that's the solution to X equals, to UX equals Y. Okay? Well, UX equals Y. This is an upper triangular matrix times X equals Y, and that's easy, and that's by, I'll write it in, back substitution. Okay, now forward substitution and back substitution are very efficient processes compared to the other things you can do with a matrix. Okay? Just takes a few steps, well, a reasonable number of steps, even if you've got a pretty big matrix. Okay? And remember, it's a computer, it's probably going to be doing these steps, so it's easy to do matrix calculations that'll tie up a supercomputer for weeks. Okay? If you do the efficient algorithms, you tie it up for milliseconds. That's kind of what it comes down to. So that's why we do this sort of thing, and this is how the process works. Now we'll do more with it in the next class.